Okay, for our lesson title, we have Computing Measure of Dispersion, and then we have lesson objectives. At the end of the lesson, you will be able to describe the uses of common measures of variation and to compute variance and standard deviation. The measures of dispersion shows how scattered the data are. It tells the variation of the data from one another and gives a clear idea about the distribution of the data. You need to be able to understand how the degree to which the data values are spread out in a distribution, which can be assessed using simple measures of dispersion to represent the variability in the data. In statistics, variability, dispersion, and spread are synonyms that denote the width of the distribution. You've learned central tendencies and even the computation of range in the past modules. This time, you will learn more about the data by solving the variance in standard deviation and how to use the values in statistical decision making. So we have three measures of dispersion. We have range, variance, and standard deviation. So let's start with range. Range is also a measure of dispersion. As you can see, we have a given formula. All you need to do is identify the highest value and then the lowest value and then get the difference of the two. It is simple to compute and it's useful when you wish to evaluate the whole of the dataset. It is not the best way to describe the spread within the dataset since it only considers the highest and the lowest values without considering the values in between. Okay, so let's move on to variance and standard deviation. So variance measures how far a set of numbers is spread out. A large variance indicates the number in the set are from the mean, far from the mean and each other, while a small variance indicates the opposite. And then we have standard deviation, square root of variance. Okay, as you can see, we have sample and population. So we have sample variance and sample standard deviation. And then we have population variance and population standard deviation with a given formula. As you can see, we have a symbol for sample variance, S square. And then we have population variance, sigma or little sigma square. And then, pagdating naman sa standard deviation, i-remove lang natin yung square o yung 2, exponent na 2. And then we have a given formula. We have summation, meaning may add tayo. And then we have x minus mean. So, kailangan natin i-compute also the mean. And then square divided by n minus 1. As you can see, same lang sila ng formula sa numerator. So, nasa ibabaw. Ang pinagkaiba lang nila, yung n natin dito sa population, walang minus 1. So, yun po yung population, ginagamit yon if we have large number of data, and then yung sample naman, ginagamit lang yon pag we have small number of data. Okay, and then for standard deviation, as you can see, square root, may dinagdag lang tayo sa formula natin na square root. Okay, kasi yung makukompute nating variance, kukuhanin lang natin yung square root nun, yun na yung standard deviation. So, dapat sa variance pa lang, tama na yung sagot mo kasi nga, kapag mali yung compute mo sa variance, may possibility na maging mali din yung sagot mo sa standard deviation. Okay, so let's have an example. Let's have a look and compare the scores of Sophia and Duff in the recent 4 summative tests by solving the mean, range, variance, and standard deviation. Okay, so the score of Sophia and Duff. We have Sophia's score 75, 75, 75, and 100. Then we have Duff's scores 80, 81, 82, and then 82. Okay, first step, we need to identify the mean. Okay. We have symbol of mean and then we have a formula to find the mean, summation of x divided by n. So, i-add lang natin yung score and then i-divide natin kung ilan sila. So, we have 75 plus 75 plus 75 plus 100 divided by, so 1, 2, 3, 4. So, we have 4. So, we have a mean of 81.25. Okay. For Sophia's score. Next, how about range? Okay. So, range, we have highest value minus lowest value. Highest value is 100 minus 75. So, we have a range of 25. Okay, for Sophia's score. Next, we have Duff's score. Again, mean. And then we have summation of x minus n. So we have 80 plus 81 plus 82 plus 82. And then divided by, so 1, 2, 3, 4. So we have a mean of 81.25 also. So how about range? So we have highest value is 82 minus 80. So we have range of 2. So same sila ng mean and then magkaiba sila ng range. Next. As simple as that. So madali lang. Next is variance and standard deviation. Okay, so kaunti lang yung score natin o kaunti lang yung ating data. So, ang gagamitin natin is sample. As you can see, we have sample variance and sample standard deviation. Okay, so yung x is the score. So, susulat lang natin dito. We have 75, 75, 75, and we have 100. And then we have x again, and then minus mean. So, yung kinumpute natin ng una. We have 75 minus 81.25 is equal to negative 6.25. Then we have 75 again minus 81.25, negative 6.25. And then we have 75 minus 81.25 is equal to negative 6.25. And then we have 100 minus 81.25. We have 18.75. Okay. Next, as you can see, we have a square. So, kailangan natin i-multiply by itself yung result natin dito. So, we have negative 6.25 square. So, meaning, negative 6.25 times negative 6.25 is equal to 39.0625. Okay, so we have negative 6.25 square, 39.0625, negative 6.25 square, 39.0625, and then we have 18.75 square. So we have 351.5625. Okay, next. So, we need to add kasi may nakalagay na summation. So, i-add natin to lahat. Okay, so we have 39.0625 plus 39.0625 plus 39.0625 plus 351.5625 is equal to 468.75. Okay. So, we have sample variance, so we have minus 1. Okay, so for our formula. So, ang numerator natin, yung nasa taas is 468.75 divided by n minus 1, which is 4 minus 1. So, we have 468.75 divided by 3. So, we have 156.25 for our variance. Okay, as simple as that. And then for sample standard deviation is square root of our variance, 156.25. So we have 12.50 for our standard deviation. So for sample variance of superior score, so we have 156.25, and then yung standard deviation naman is 12.50. So next we have DAP score, which is 80, 81, 82, 82. So we have 80, 81, 82, and then we have 82. Okay. Same process. So we have 80, 81, 82, 82. So minus. So yung na-compute natin mean kanina is same sila. So we have 81.25 also. Then we have 81.25, 81.25, 81.25. So 80 minus 81.25 is negative 1.25. Then 81 minus 81.25 is negative 0.25. And then we have 82 minus 81.25 is 0.75 and also 0.75 kasi parehas silang 82. So next, same process again, negative 1.25 square is equal to 1.5625. Then we have negative 0.25 square is equal to 0.0625. And then we have 0.75 square is 0.5625. And then same, 0.75 square. We have 0.5625. Okay, same process. I-add lang natin yung result. So we have 1.5625 plus 0.0625 plus 0.5625 plus 0.5625 is equal to 2.7. Okay. So we have, okay, minus 1 again. So we have 2.7 divided by, we have 4 again, minus 1. So we have 2.7 divided by 3. So we have 0.91674 variance. Okay. And then for standard deviation, we have a square root of 0.9167 is equal to 0.96 for standard deviation of DAP score. Okay. So, as simple as that. So, gumamit kayo ng table para mas ma-illustrate kung paano kinukompute yung variance and standard deviation. Okay. So, conclusion. Sophia and Duff have the same mean because of 81.25, but different range. So, Sophia is, mean nila is 81.25. And then, ang range of Sophia is range of Sophia is 25, and range of Daphne is only 2. And then we have, okay, and then also yung range standard deviation ni Sophia is 12.5 or 12.50. And then standard deviation naman ni Daphne is 0.96. Okay. So by that, so we can conclude that DAP score are closely related to each other. Thus, in general, DAP is consistent with her performance. Kasi nga, yung difference lang, o yung standard deviation niya is mas maliit kesa kay Sophia. Okay. So, mas greater yung standard deviation ni Sophia kaysa kay DAPS. Okay. Simple as that. So, that's all for today. Thank you.